All right, welcome back to AP Physics 1, Unit 1, Kinematics. So this is an important topic, so topic 1.3. I'm splitting this topic in AP Physics 1. You'll see that this is actually one single topic in your AP classroom. But I'm going to split it because it was too big of a topic to do as one single video. So I'm splitting representing motion into two subtopics, right? We're going to talk about in terms of equations in this video. And in the next video, we're going to talk about in terms of graphing. Okay, two very important ways that we represent the motion of an object. So different ways that we can represent motion, right? So we can talk about in terms of motion diagrams. We can talk about in terms of figures, graphs, equations, and just simply narrative description, right? So a lot of times with the narrative, I've taught, like how far, right? How fast, right? So we're using vernacular to explain what is happening. Motion diagrams, they're also very important. So what it does is it's a dot representation of the motion. So it's like I have something that tracks, puts down a single dot every set time interval, say 1 second, 2 seconds. So what this does is it shows me that it changes, right? It displaces a certain amount every second. And then you have other versions. So if I'm speeding up, what you'll see is the dots will get bigger, or the gap between the dots will get bigger. And if you're slowing down, they go the opposite, right? They're going to get closer in the end, right? So this is what we call constant velocity. This is speeding up, and this is slowing down, okay? So you can see how those look. All right, figures, right, pictures, easy way to look at it. You got a couple pictures off to the right-hand side there. But in this video, we're going to focus on the equations. In the next video, we're going to focus on the graphs. In fact, those motion diagrams turn into graphs if you stretch it through time. All right, so in physics, there's a very important set of equations that can be that are used to describe motion. And what we do is I like to call them CAKE, constant acceleration kinematics equations. So here's one difference between Physics 1 and Physics C. In Physics C, there's no assumption that the acceleration is constant. But here in Physics 1, the acceleration will always be constant. Now, there's a couple sections in which we don't make that assumption just so we get a little variation. Because if you don't make the variation and just say everything's constant acceleration, the graphs are just going to be straight horizontal lines. And that's no fun to do, right? You just really find like the area of a rectangle, right? Where you can do like the area of a triangle, okay? So here are the constant acceleration kinematics equations. The first one is going to be V equals V0 plus AT. So final velocity equals initial velocity plus acceleration times time, okay? So this is actually the equation of a velocity time graph. And we'll get into the graphs in the next video. The next one is delta x equals, VOT plus 1/2 AT squared. This is actually the equation of an XT graph, position time graph. But on the formula sheet, I want to make sure that we do distinguish. You'll see this equation written like this. So one thing to note with this equation, note that it is a quadratic, okay? And then the final equation, I like to call this the equation that time forgot, because you'll see that there is no time in the equation. And something you notice that every equation has there's 5 potential variables, and each one of these 3 equations has 4 of the 5. There's always one missing, okay? So if you want to talk about what is missing from the first equation, well, displacement's missing from the first equation. If you want to talk about what's missing from the second one, well, its final velocity is missing. And then in the last one, as I mentioned, it's time, okay? So when you see this x equals xo feature, well, that means displacement. Okay. This is just how I'll try to give you the way they write it on the formula sheet. But so what I wrote there in black and have now the x equals xo in a green square or a green rectangle, that's how they write it on the formula sheet. I like to write it like it is in blue, okay, because that helps us when we talk about graphs. All right. So we're talking 1D motion, right? We haven't moved into two-dimensional motion. So near the surface of the Earth, there's a special vertical acceleration called that is caused by the force of gravity. So note that it's constant and downward. So constant means not changing. Downward means always pointing down. So if you look at Felix Baumgartner, who did the jump from space, he's experienced an acceleration that is constant, and it has a value of 9.8, okay? Or as you can see over here, it's approximately 10 meters per second squared, right? And this value is very important because when we talk about free fall, when we talk about projectile motion, this is the acceleration of free fall. Okay, this is also called the acceleration due to gravity. So if you get a question where there's like a ball dropping or something's falling, all of your accelerations get turned into this number, right? So they get turned into this negative number, okay? And we use 10 for simplicity, especially on multiple choice questions. If it's a free response question, you have to check to see what they're asking you, or they may say, hey, use G equals to 9.8. So they're telling you what to use because that's what they're going to publish in the answer in the free response question scoring document. If not, if it doesn't say anything, you can just simply use 10. All right, so let's look at an example problem using these equations. So here we go, right? So we have a ball falling from rest, right, from the top of a roof. We want to know how far did it travel and what was the final velocity at the end of 5 seconds. I'm going to split this slide into 2 sections, right? So the first thing we're going to do is we want to see how far did it fall. So something you note is that the initial position, set it to 0. This way, when you substitute in, you already have like a 0 value, okay? The other thing is if we're just dropping it, our initial velocity will also be 0, right? It's not like I'm throwing it up or throwing it down. I'm just simply dropping it, okay? So always start with the equation. That's something important in physics, and always show your work. Just don't make an assumption that if you just put an answer, they're going to know what equation you used. In fact, these are the points that are on the AP test that a lot of students don't use. Okay, so I know that this is 0. I know that initial velocity is 0. Now, a common mistake is right here is that students will cross out the V0, but forget to cross out the T and leave the T in there, right? So leave time in there and change the answer completely. So note that I crossed everything out that tells me that, hey, I don't have to worry about that middle part, that VOT, right? So what's left? 1/2 AT squared. Now I can just simply plug in. So X is equal to 1/2. Now, because this is a free fall, I'm going to use 10. It doesn't say, hey, use G equal 9.8. If it does, then I would have to use that value. Okay, so 10 is my acceleration. 5 is my time. So now I take my handy dandy calculator, 0.5 times 10 times 5 squared, which is 25. So after 5 seconds, this ball has fallen 125 meters. Okay. Now, that's got to be a really tall building, 125 meters. If you think about it, you multiply that by 3, it's about 400 feet, right? So, I mean, it's a really tall building. There's have to be a high rise, right? So it would be at least a 40-story high rise almost. All right, so now let's go to the other side where now we're going to figure out how fast is it moving. So I use my V equals VO plus AT. So, I mean, sometimes students always ask, how do I know to use which equation? So how far always goes with a position, right? This says, what is the final velocity? So I know I've got to use my V equals VO, right? Could you use the V squared equals VO squared plus 2A delta X? Yes, you could. but I always make an assumption that this is going to be a wrong answer. I know it's not wrong. I plugged everything in my calculator right, but assume that this is going to be wrong so that you can go and use known values to do your equations. Okay, so cross things out. The only thing that is 0 in this equation will be V0. Okay, so now my equation simplifies to V equals AT. Again, I'm in free fall, so I can use 10, unless, again, if it says use G equals 9.8, use G equals 9.8. If not, I can use 10. So it's telling me after 5 seconds, the ball is falling 50 meters per second. Okay, now, so terminal velocity is something we're not going to talk about. Really, we'll mention it, but not talk too much about it. Has it reached terminal velocity yet? We don't know. Okay, that's more of a Unit 2 question than it is here in Unit 1. Okay, so this is a new focus for AP Physics 1, is this idea of representing motion. So make sure that this is something that you follow.